pedometer is a portable device which measures the distance walked by a person using either electrical or mechanical means of detecting the number of steps a person takes. Originally designed for athletes, they are now used by the everyday person as a way to keep track of activity levels, and it can also be used as a motivational tool. This device can either be worn on the wrist, attached to a belt or shoe, or kept in a pocket. Some say the origin of the device can be traced all the way back to Leonardo da Vinci. Da Vinci sketched a device with a pendulum arm that would swing with each leg motion and track distance traveled. Others would give credit to a Swiss watchmaker named Abraham Louis Perellet, who created a device to measure the steps and distance while walking in 1777, based off of a mechanism to power a self-winding watch. The mechanical pedometer that we've come to know was first introduced in the United States by none other than Thomas Jefferson. However, pedometers were not used to promote physical activity until the mid-1960s in Japan. Currently, pedometers are primarily used to track the amount of physical activity a person gets per day. The Surgeon General recommends everyone take at least 10,000 steps per day. This number is criticized as being too general, being too high for the elderly, and too low for most children. It can be agreed upon, however, that walking and being physically active has its benefits. As shown by the figure, walking every day can help improve balance, strengthen back, improve posture, improve cardiovascular health, and boost endorphins. It can also reduce the risk of osteoporosis, type 2 diabetes, arthritis, mental health, and other diseases such as cancer. Clinical studies show that pedometers increase activity levels, and in doing so, reduce blood pressure and body mass index, or BMI. Specifically, in 2007, Stanford ran a study, and they concluded that pedometers can be used as motivators. In this study, physical activity of the participants increased by 27%. However, this result could have been obtained via the Hawthorne effect, because the participants knew they were being studied and could have altered their physical activity accordingly. A Norwegian study done in 2008 directly refuted the results of the Stanford study. It showed that there was no net change in physical activity if no goal was proposed, even with the use of the pedometer. Therefore, they concluded that the goal to achieve the desired amount of steps is what motivates people, not the pedometer itself. There are two main types of pedometers: spring-levered, or mechanical, and piezoelectric. Spring-levered pedometers use a horizontal lever arm that is suspended by a spring that moves up and down in response to vertical accelerations of the hips as the user walks or runs. The movement opens and closes an electrical circuit and registers a step as the lever arm makes contact. This makes a ticking noise every time it does so. Mechanical pedometers must be placed in a vertical plane, perpendicular to the ground. If they tip forward into a horizontal plane, the step will not be counted. Here is a simple algorithm as to how a spring-levered pedometer functions. Before each stride, the circuit must be open. Then during each step, the circuit closes. There must be a certain amount of time between steps for the stride to be counted. On the other hand, piezoelectric pedometers use a material such as quartz that generates an electric charge when it is mechanically deformed. Electricity is generated to the piezoelectric crystal, having no net charge. This is due to the electric dipole moment vectors cancelling each other out. Upon compression of the crystal, the dipole moment vectors move, making the material gain a voltage. Piezoelectric pedometers use a horizontal cantilever beam with a weight on the end that compresses a piezoelectric crystal when subjected to movement. This generates a voltage proportional to the acceleration from the compression of the weight arm, and the voltage oscillations are used to record steps. Unlike their mechanical counterpart, piezoelectric pedometers are silent when in use. Pedometers have been known to not be the most accurate devices, and some studies show that they have up to a 50% error. Errors can be due to a false indication, misreading of steps, or alteration in stride length. A calibration is required for the standard stride length, and if a step deviates from this step will not be counted. This is because pedometers function by multiplying stride length and number of steps to get total distance traveled. Also, as mentioned before, mechanical pedometers will not count a step if the device is horizontal or parallel with the ground. The most common pedometers used today are found in a variety of devices. Fitbits and smartwatches measure the number of swings the arm takes while walking to count steps. Smartphones, such as the iPhone, use a motion processor to detect vertical accelerations. Other devices, such as apps on the iPhone, use GPS to track the user's location to measure distance traveled.